Hello, YouTubers. This is a new session where we get to take our llama to talk to a database offline, right? So we talked a little bit about, how to like really watch this series. It's really important because in the beginning we talked about I want to run AI offline. I don't want to pay money for it. I want to run it whenever I want, however I want. I want to just be able to interact with it without having to go over the network latency or over the wire or anything. We got that out of the way. And then we talked a little bit about how you fine tune your model. So you're basically picking up again offline based model and you fine tune it on new pieces of information that you can communicate with the model with later, about these pieces of information. We talked about the standard and how we kind of fine tune the model according to the standard. And then the third video, we're talking about how do we can generate the proper data for fine tuning, right? So basically, you could substitute, video number 3 with 2 and 2 with 3 because you need data to fine tune, but you can't fine tune without data. You could do that. That's fine. But the third video, we're basically talking about how to generate data. So I give it a PDF document, and it turns it into, I don't know, text, and then that text turns into a JSON L file that you can fine tune. What I'm going to talk to you about today is even bigger than that, okay? You want your model to be able to learn in real time. Sometimes you can't wait 8 hours to kind of fine tune your model and offer a real time kind of engagement and interaction. Let's just say you're on a news channel, right? In the news, news are changing all the time. You're getting new news all the time. That's why they're called news from the word new. They happen all the time, new stuff, right? And you want to kind of incorporate AI to be able to kind of search through the latest news and kind of give you the gist of it, like maybe on your way to work or something, right? And you can't just collect news all day long and then fine tune it for maybe 24 hours, depending on how strong your hardware is, so you can listen to the news from 2 days ago. That just doesn't make sense, right? So that's a real requirement. You have a real requirement of making sure your AI model can learn in real time, super fast, with the latest and greatest information. So let me just show you. Let me kind of introduce you to something cool called RAG in AI. And what RAG stands for, it stands for Retrieval Augmented Generation. It's basically a framework or an idea that allows your model to communicate in real time. So let's just draw this a little bit. So remember, we had this, we had a llama model. It could be a base model, it could be a fine-tuned model, it doesn't matter, right? And you want this llama model to be able to talk to a database, right? So you can fine-tune it. It could be already fine-tuned or whatnot. It doesn't matter. You want it to talk to a database. And this database is updating all the time. So, people are pushing new data into this database all the time. So this is updates happening all the time. And your database is getting all that data, all that new data all the time. But your AI model is also able to answer and handle questions. So when you come in here and basically talk to the CLI or the API or whatever you choose to do to interface with this AI model, that's your GGAF model talking to maybe a Llama CLI like this, right? You can basically go and say, hey, tell me about, I don't know, the score of, to Barcelona playing against Real Madrid, for instance, or whatever, right? And it's getting that data in real time about that game that's happening. And more importantly, it's able to answer you with super accurate, kind of answers, right? It's giving you the most accurate answers. How do we do this? Listen to me very well. That's all of that. That's what RAG is, right? Retrieval augmented kind of model where it allows you to kind of learn in real time. Let's talk a little bit about this. In order for this llama model, this guy right here, to be able to learn from a SQL database, right? We need to turn everything here into something called vector embeddings. A vector embedding. What is a vector embedding? A vector embedding is the ability to go and say, okay, our database has something called cat. Listen very well. Cat. We have something called kitten, and we have something called car. Okay? And this vector embedding will tell you that cat and kitten are much closer to each other than a car. How does it know that? How does it know how to do that? I'll tell you how. It knows that because we're going to use a new model. You can also run this model offline. That kind of tells you, think of it as a database. And this database basically says, hey, there are vector embedding values. Let's just kind of give you some examples. I'm going to try to simplify it for you. It's going to say, hey, the vector embeddings, the values for this guy is more like, let's say, 020, right? 07, 01, like that. And the kitten just so happens to be 018, right? 01, and maybe, no, maybe this is 06 or 08, right? And maybe this is an 02. So you can see there's similarities between these, even though they're not exact, but there's similarities, right? Versus a car, which would be something completely off the charts. I'll tell you what this car is. This car is more like, this is like 80 or 90 versus 1 versus, I don't know, 15. So the vector embedding basically tells you, let me take that data in your database, this text, and let me convert it into numbers and let me find out the similarities between these numbers, right? So if your database says we offer services to kind of brush cats. We offer services to clean up and brush cats. And someone comes and says, do you offer services for kittens? So it basically goes and says, yeah, kittens is closer to cats. I have records for a cat. Then I'm going to determine that the answer to the kitten is the same answer as it is for the cat. It's not always 100% accurate, but it's most likely, especially if you're not too deep, too technical, or too abstract, it's going to give you the right answer, right? But the relationship between a car and a kitten, it's very far. It's very far. Now you might ask yourself a question like, how does it know that? Like, how does it know that a cat and a kitten are closer to each other than a car? This is like reasoning and context. I'll tell you how. They train it on ton of data, right? Something called the pile. Literally, go look it up. The pile, right? It's basically a massive data set, open source data set, right? And this data set kind of tries to build these vector embeddings and tries to understand, oh, well, cat and kitten seem to occur in the same context more often than a car and a kitten and a car and a cat. For instance, you say, brush your cat, okay, and brush your kitten. Yeah, that's similar. That's the same context. But nobody ever says brush your car. That's weird, right? Nobody ever says, did you feed your car today? But people will say, did you feed your cat? Did you feed your kitten? Did you go to the vet? Did you take your cat to the vet? Did you take your kitten to the vet? Versus basically saying, did you take your car to the vet? It doesn't make any sense. So that's what vector embeddings are. Okay, so a little bit of a deep dive, but let's just put that back here. And let's say, so this llama model, what basically happens is that we use another AI model that will basically go and say, turn this into vector embeddings. So this becomes vector embeddings. And then use a library that will basically convert these vector embeddings based on the question. So you're asking a question, right? This is your question coming over here like this. This is the question here. It'll basically say, here's your question, and here's the conversion. And based on the question, it will try to convert certain elements of your question to the nearest and closest vector embeddings to the data that exists in your database. It's actually freaking brilliant if you think about it, right? Because it basically says, I can find the reasoning behind the system and the questions and the context, and let me find this is basically some vector embedding database, vector embedding search database, right? Something called FIAAS, Facebook open source library, something or other, and it basically runs offline, open source, super fast. It runs with millions of records. It's amazing. So that's basically what we're going to do today. We're going to create a database table. We're going to put some information in it. We are going to write some code that talks to our database model, and then we're going to ping that model. We're going to CLI that model and basically see if it can answer questions that make sense to us. Does this sound like a plan? So let's start from the top. I'm going to kind of blur everything out. I'm going to just go and say everything, set everything color to nothing. If I can do that, here you go. Okay, and then let's start from the database. This is a database right here, right? That's a terrible color. Maybe this one. Okay, here's a database. Let's go and create a database. I have a thing called SQL Management Studio, but you can connect it to SQLite. I don't know, whatever you want to connect it to. This is just a simple local database server that's running on my computer. and I'm going to go and create a new database. And I'm going to call my database llama.db. Let's create llama.db. It's a simple database. And then inside that llama.db, I'm going to create a new table. I'm going to call it knowledge, right? So this is just content, and this is in varchar max. I know the nerds are going to freak out about me kind of making everything max like that, but it's for the purposes of this video, my dear fellow smart people. I think it's fine. So knowledge. So a database called a database table called knowledge, right? And inside that database table, there is one column that's called content. Okay, so far so good. If I go and basically edit the top content in here, I can add a bunch of content. And what I'm going to do today is just add really, a bunch of content. Let's see if we can add some stuff in here. Brokers, let's see here. Brokers are the last point of contact between a system and an external resource, right? Brokers cannot have business logic in them, something like that. Brokers are, let's see, are a thin layer that abstracts away configuration details to external sources communication. Something like that, right? And I'm gonna, just a very simple bits and pieces of data that I'm adding in here. And basically, I'm going to teach AI in real time, and we're going to add data to it, and we're going to ask it about new questions as we kind of learn about this. Okay, so that's the easy part, actually. Okay, we've created a database that has these details in it. Great. Now, let's get to the fun part. The fun part here is to basically go and say, I want to start a new kind of Python project. I want to start that from scratch for you because I want you to actually see the whole thing because there's a virtual environment thing going on and all of that. So let's just do llama loves rag. Let's create that. This window. Great. Okay, first of all, we need to install some dependencies, right? In order for us to install these dependencies, we need to be able to go and say, well, these dependencies are important, and we need to understand what these dependencies are, just to kind of be able to kind of work with them. So I'm going to create a new Python file, rag it, rag it out. I promise you, this is one of the most fun things I've done so far. I mean, AI is very exciting, but this one is really, really fun. Okay, we need a bunch of libraries, right? The heck that FAISS, that's a Facebook open source library. The llama.cpp, so we can ping the model, and we can ping the model anywhere we like. But then also the sentence transformer, super important. And then there is pyodbc. This is how we're gonna talk to the database, right? So this is talk to database, right? This guy here is I want to be able to prompt my AI model, right? This is open source Facebook indexer for vector embeddings, right? And that's actually the vector embedding model kind of thing. Okay. NumPy, I don't remember what NumPy does. We'll find out. Okay. And then OS to kind of find files and stuff like that, all that good stuff. Okay. We need to install these things, right? Let me find the libraries here. Pip install transformers. It's going to take a second, I promise. Super fast internet, super fast machine. Should take care of it super quick. There we go. NumPy is I just looked it up. It's a fundamental Python library for numerical computing. Okay, provides supports for large multi-dimensional arrays and matrix. Fantastic. Okay, we know now what it does. Okay, is this guy done? It's indexing, it's building things. Okay, while it's doing that, I'll let it kind of work on that. These will disappear. I don't want you to just sit there and wait for that. The first thing I want to do is just kind of get that vector embedder, right? The embedder, it basically an AI model specifically converts text into vector embeddings, right? This model, its main responsibility is to basically get you that database, that pre-existing knowledge, the fact that a cat and a kitten live in the same context kind of thing, okay? So what I'm going to do here is I'm going to say embedder equals, right? And this is the sentence transformer. See, this guy is very smart, and I don't want Bert. I want actually the all mini lm L6. Let me find the exact. There you go. This guy right here. Okay, so this is a sentence transformer. It's coming from this guy, and I created an embedder, right? The next step is that I want to connect to the database. Remember, in our model here, this guy is already done right here. Now I want to build this guy, right? I want to connect to the database through the vector embedding, right? But you need to connect to the database first. So let's kind of create this code in here where it basically connects to my database. We already created a llama.db. Big B is basically my computer name. That's the server that I'm running on. You could probably use localhost, but that's what worked for me. Big B, right? This is my actual server machine name. For instance, I kind of left a comment for you here just so you know. You need to have the ODBC driver 17. The code, the error will tell you if that's not installed, but if I install it again, it says you already have this. I want to make sure the database name is correct though. So llama.db llama.db. That's exactly what I did here. Llama.db. Perfect. Okay, and the rest is basically history. We're basically saying connect to the database through that connection string. If you are communicating with like a remote database, you're going to have to provide something like a username and password, right? So you're going to have to go and say the username is this, the password is this, unless you have like an Azure Active Directory or some kind of model that allows you to do that. So far so good. So we created the embedder, right? And then we have the database. What's the next step here? The next step that I want to do here is actually do basically the actual work for the indexing, right? So I want to go and say, give me all the knowledge in this database, give me all the records in this database, right? And turn it into documents, like just raw text, line by line by line by line. Okay, so it's going to read all the entries in your database in this content knowledge and load that knowledge base. So let's go and do that. It's very simple. You're basically going and saying, give me the go and query from knowledge, select all content from knowledge, and basically put all of that into documents. This is just raw text. That's all that it is, just raw text, just like that. Okay? Now, with that, let's go ahead and move on to the next step. The next step here is to basically go and say, now that I loaded all these documents, I want to turn them into document embedding. Now, okay, no, this is where the magic happens, right? Every document, every line that I had about the brokers gets converted into vector representations. These are the numbers that I was just talking to you about when we talked about cat and kitten and whatnot. These vectors will be used to kind of find the similarity between what the prompt is and what you're actually working with. So we need a doc embedding that basically will load these kind of documents as document embeddings, right? Now, when that's done, we need that create. Now we're going to use that Facebook AI similarity search, which is basically to find the nearest neighbor. Cat, kitten, there's cat, kitten, lion, tiger, right? They're kind of in the same context, but a kitten is much more closer to a cat than a lion and a tiger based on all that training and all that stuff. So I'm going to go ahead and basically use that finding the closest neighbor, that's that dimension guy, and creating that index. And then we're going to need to build a dictionary. So every single document in your database, every single row that we pulled in that database, we're basically going to give it an ID, and basically it links it to a result based on the indices back to the original document text. So that's that part right here. Okay, and then we need to load the local model. So this is the part where we basically go and say, this is my local database. So this is done right here. This part is done. And then there's this local database model. We already done this before many, many times. Even this guy is done. We already did that Facebook FAISS kind of thing. We need to kind of just build that part in here, which is the llama model with the CLI. So what I'm going to do here is that I'm going to go and say, give me my local model. I already have that local model downloaded and installed, like on my machine. It's not installed, just downloaded, right? So I'm just going to reference it in here. So you have this. This is the model path. Make sure the model path exists. You don't have to use this. This is like more like a validation kind of thing. And then I'm basically loading it in this llama kind of class so I can ping it. Now here comes the fun part. This one is the one that we're going to have to stop at, and I kind of have like a very, very deep explanation for each and every step in here, there's this function called query rag. Now pay attention because this is what I was really trying to get to from the beginning of this video. What this query rag function do? It will convert your input. See, the explanation is right here. The input into a vector. Okay, we already have this. And then search for the index to find the most similar document vectors, right? Top K meaning top token, like the closest one. And then find the documents that meet these indices. And then combine that document in the context of the question, like the question that's coming. And then add see the prompt will have this context and then the question, and then let AI kind of spit out the answer. You see what it's doing? So basically saying, go and find the nearest thing that's relevant to that question that came through, and then add it as a context. It becomes part of the prompt that we're hitting the AI model with, and then add the user question, the question that came through. If you look here, this question was part of the encoding and searching right there, right? So we're just adding it as part of the prompt. Like we worked with the question before we even hit the AI model. So we know that we're looking for these particular pieces of information. It's just like Soundix. It's much smarter, but it's just like Soundix if you're familiar with what Soundix is. Lalea's part is the easiest part. The easiest part is to basically just go and say, hey, I want to ask this guy a question, so I'm going to drop that in here. Instead of what are company hours, we can say something like, what is a broker, maybe. Now notice we didn't feed the database anything about what a broker is. We just said broker are the last point of contact, cannot have business logic. We just said a bunch of things about brokers, right? But we never taught it to kind of say what a broker is. Like that particular question was not part of that question. And then we're going to add new things in real time. Now the only thing left is just for us to kind of run and see what happens. Here we go. It's going to spit out a whole lot of garbage, and then eventually it's just going to give you the answer. Look at this. A broker is a software that sits between the system and an external resource. It provides, let me kind of take my face out so you can see this. Watch this. It provides a thin layer of abstraction that allows the system and the external resource to communicate in a standardized manner. Brokers can have no business logic, but they do need the configuration details to communicate with external resources. How beautiful is that? That's freaking beautiful, right? I'm going to add a new piece of information just to show you the point of RAG, right? I'm going to add one tiny piece of information here that basically says brokers cannot talk to other brokers. Just as a rule, according to the standard, right? So I just added a new bit of data into my system, right? Let's see if this guy actually can pick that up. Here we go. This is the fun part. A lot of garbage. It's not really garbage. It's a lot of smart stuff that I just don't understand with my limited knowledge, but it's definitely something exciting. Yeah, a broker is a software, whatever, and then external resources cannot have business logic, standardized manner, and then there's a bunch of stuff down here. I don't. This is just like more like hallucinations, but if you look at the answer, did it actually? Let me ask it the question specifically about that part, right? Can a broker communicate or integrate with another broker? See, it's not the exact same thing that I put in the database. Let's just run this thing and see what it does. Here we go. Can it? Where is that? Brokers cannot communicate or integrate with other brokers. How beautiful is that? This is just freaking awesome, right? That's just real-time data being updated, right? It's just beautiful. We need to figure out the the hallucination based on the number of like tokens that we're allowing the thing to have. But let's try to ask it even smarter questions just for the road. One for the road, and then we wrap up this amazing session. Um, let's just go and say, um, let's just say that our last point of contact between the system and an external resource. Okay, let's just go here and ask a really smart question. Can a broker use something else to communicate with a database? Let's just see how smart this thing is. So let's go here. This is a hard one, right? Because the answer is yes and no, right? It depends on what something else may be, right? Something else could be literally another broker, or it can be just a configuration or a library. It can be many things. Look at this. It says yes, brokers can use other mechanisms such as risk. That's a good answer. That's a very, very good answer. That's completely correct according to the standard, right? So this is exciting. This is beyond exciting because now your llama model is so much smarter than ever it can be. It's not just able to learn about your world offline. By the way, all of this running offline, obviously, but I mean, except for the part where you're downloading the model. Like, actually, I need to point that out. It can be offline. I just need to make sure that you understand that this part in the code, the all mini LM L6 V2, you can just download that. Like, just download it on your local machine and just call it the exact same way you're calling this model path. And now everything is running offline. Why that's important? If you're building something serious and you really want to engage AI in real-time learning, like let's say, and I'm gonna make a video about this. Let's say we have this little Victor guy. Like this is a robot. He's asleep right now, but we're gonna wake him up by holding him like this. And this guy needs to be able to learn about the world around it in real time, right? So you want it to learn about, oh, there's a screen here, there's a Coke in here, there's a bottle of water in here. You can't just go and say collect the data and then fine tune it later and then make Victor make decisions as it's navigating a surface as a robot. You can't do that, right? You have to teach it in real time. This is it. This is it. I really hope you had fun, dealing with this, watching this session. I don't claim to be in depth about the little embeddings and Victor details, but I just know enough to be dangerous and be able to share that with you. Of course, the code, you're gonna find it in GitHub. Let me kind of get the GitHub piece for you. So in GitHub, you will see, if you go to the llama offline, if you go to this particular repository, just give me a second there, repositories, training llama offline. There, and I can see some people already kind of hit the like on the model and whatnot. Uh, there it is. It's beautiful. You get to kind of, you have it right here as a step 5, rag it. It's called rag it. And it has all the details you need. You just need to kind of run it, against your system. I hope you use this for something useful, that help people kind of use AI for something useful. If you found this video nice and useful, please share it with other people so they can get up to speed on AI and how AI works offline and all that. And as usual, if you have any questions, comments, concerns, please feel free to drop a comment in the comment section. And don't forget to like and subscribe. I'll see you in another video. Take care.